Okay, so we are going to begin our chapter working with the fundamental identities. Okay, and you have no idea what I'm talking about. But before we get to what the heck identities are, I do want to practice doing some algebra with trigonometric expressions. So this chapter, we are basically going to work with expressions and equations, but they're going to have trigonometric functions in them. And we can do the same things we do with X's and Y's and whatnot, but now we just have sines and cosines. Thank you. Okay. So the first thing I want to work on is factoring. So go ahead and copy down this expression here for me. Okay. We're gonna have to get used to using our algebraic skills with trig. I know it sounds really weird. It's gonna feel a little awkward at first, but once we get used to it, it's not so bad. Okay. So we have cosine squared minus sine squared, and I want us to factor this. Now, if this is giving your eyes a hard time, I want you to think of this. C squared minus S squared. How would we factor this expression right here? Not quite. What's another word for subtraction? Difference. And what is this? A square. So this is the difference of squares, and we factor that like this. Do you remember that? No? Okay. So if we have a difference of squares, we can factor it a plus b, a minus b. In this case, we're going to factor it cosine of x minus sine of x times cosine of x plus sine of x. If you write them the other way, we'll be okay. Multiplication is commutative, so it will work out just the same. I also could give you like a trinomial and ask you to factor it. Okay, when I mean trinomial, like x squared minus 4x plus 3. We're going to factor this expression right here. Now, my suggestion to you is if this is hurting your eyes, like, man, I don't like this. Okay, well, let's come over here and let's write it as 4t squared plus 1t minus 3. Okay, instead of tangent, I just wrote t to make it easier for us. Okay, so let's see if we can factor this expression right here. Okay, well, what multiplies to 3? 1 and 3. Okay, now we know one needs to be positive, one needs to be negative. We'll figure that out in a little bit. Now we have two different options for 4t squared. What do you want to try first? Okay, so we could have 4t and 1t. Okay. So if I were to FOIL this, our outside would give us 12t and our inside would give us Yeah, that's probably not happening, huh? Okay, so let's try this. 1t times 4t. This would give us 4t and this would give us 3t. Hey, which one should be positive? We have positive 4t and negative 3t. Then those add up to be our middle term. Okay, well, if 4t squared plus t minus 3 factors to this, then if we have 4 tangent squared x plus tangent x minus 3, then that would factor to tangent x plus 1 times 4 tangent x minus 3. What do you think? If you can factor normal polynomials, you can do this, okay? If the trigonometric functions are throwing you off, rewrite them over here as letters and do the algebra with letters, and then just apply it to your trig functions. Okay, now this is something that you're going to practice. We're going to see a little bit of it today, but we're going to see a lot of it next week. Okay, but I still need you to practice so that when we get there, you're not like, what's happening? Okay, but the biggest thing that we're going to do today is work with our fundamental identities. So there are 9 identities that you need to know, and they're going to become sort of like the unit circle, second nature for you. Okay, it's not something I'm gonna like have printed out on your quiz. We're not like get a note card with them written on it. Like, these are something that we're gonna work with so much, you're gonna need to know them. Okay, and what's kind of cool is you sort of already know them. Okay, so we are going to start with the reciprocal identities. Ooh, there's a buzzword. Reciprocal. Sort of harped on you about reciprocals, right? Let's. Nick, give me an example of 2 trig functions that are reciprocals. Tangent and cotangent. That is really unfortunate. Okay, so we know that the cotangent of theta is 1 divided by the tangent of theta. Oh. Hank, what's another one that we know? Okay. Luke, what would this third one be? Yep. And it is 1 over cosine. Now, those are the main 3, but we're also going to understand that sine is 1 over cosecant. Cosine can be written as 1 over secant, and tangent can be written as 1 over cotangent. Okay, now, do you notice how I wrote thetas in all of them? Okay, it doesn't have to be theta. Be the sine of x equals 1 over cosecant of x, or it could be the sine of 30 degrees equals 1 over the cosecant of 30 degrees. as long as the angle matches on both sides, it holds true. So the angle could be theta, x, 55, whatever, okay? I'm going to write theta right now, but we're going to see in our work that sometimes they'll use theta, sometimes they'll use x, sometimes they'll use t, okay? So let's go to our next set, the quotient identities. The quotient identities. Quotient means what? Okay, that we're dividing. When we were on our unit circle, was there ever a trig function that we had to take this divided by this? Tangent. What did we take? Y divided by x. And what did y stand for on the unit circle? Sine. So y was sine, x was cosine. So the tangent is the same thing as sine divided by cosine. You've known that all along. We've just never written it like this. Okay. And since the cotangent is the reciprocal, we can write the cotangent as cosine over sine. Those two identities are going to be very helpful. Okay, last but not least, let's talk about our Pythagorean identities. I bet this deals with what? The Pythagorean theorem. How in the heck? Okay, what did I draw here? Circle. Don't draw this. I'm going to show you something. Okay, so this is the unit circle. Let's go with it. Okay, any coordinate on here, we know that the x coordinate represents the cosine of that angle, the y coordinate the sine. Okay, what do we know about the radius? 1. Since our x coordinate is cosine theta, then this distance right here is cosine theta, because that's x. And then we travel up the sine of theta. So if I use the Pythagorean theorem on that cute little triangle right here, we have side squared plus side squared equals hypotenuse squared. Or, write this down, sine squared theta plus cosine squared theta equals 1. This will be one of the most important ones that you have to use. Okay, some of you are wondering, why do these even matter? Okay, well, first of all, you're in pre-calculus, so it's got to matter for something next year. Those of you who go on to calculus, we use trig identities in both of my classes fairly often. Okay, so this is us getting to practice them. Okay. Now, this is the main one, but there's 2 more that we need to remember. Okay, don't write down what I'm doing quite yet. Okay, the other 2 we can get, you can either memorize them or you can remember what I'm doing right here. Let's say that we divide both sides by sine squared theta. If I were to do that, then what is sine squared over sine squared? 1. What did we say cosine over sine was the same as? Cotangent. So cosine squared over sine squared is cotangent squared. And then what did we say 1 over sine was the same as? So 1 over sine squared is cosecant squared, okay? What I wrote right here in purple, 1 plus cotangent squared equals cosecant squared, please write that down. And then there's a third one. I'm going to take both sides and divide by cosine squared this time. Don't write that down, but write down what I'm about to do. Sine over cosine is the same as tangent. So we have tangent squared plus cosine squared over cosine squared gives us 1 equals 1 over cosine squared is the same as secant squared. Here are your 3 Pythagorean identities. These 3 are the 3 that you didn't know about until today. I feel like the other ones we were kind of working with without actually like saying that's what we were doing. We were taking tangent as y divided by x. Well, that's sine and cosine. We are taking cotangent as x divided by y. Well, that's cosine divided by sine. Okay, so these 3 are the new ones. Okay, but these right here, you need to eventually know by heart so you can work with what we're going to do over the next 3 weeks. Okay, now I'm not saying you have to have them memorized by tomorrow. All right, we're going to work with them enough to where they're going to become familiar. Okay, but my suggestion to you when you do your homework tonight is to write these at the top of your paper. That way you have them to reference as you're working. Okay, now what are we going to do with these? Our goal today is to take expressions and simplify them. Okay, so here's our first example in this set. We are going to take a trigonometric expression and we want to rewrite it to make it look simpler. Give me one thing that you notice up there. I see sine of x 2 different times, right? Okay. Something I want you to be on the lookout for is a greatest common factor. We have 2 terms. Both terms have a sine of x. So we can factor a sine of x out of our expression. Now, when we factor out sine of x, left over here is 1 minus left over here is cosine squared. Okay, now I am going to ask that you give me some explanations as you do these things. Okay, what did we just do? We factored. Okay, factored out the GCF. What'd you say? Okay, I'm sorry that you feel that way. These aren't quite as formal, and I'm not going to be like super picky about what you write right here. I'm asking you to write these things for 2 reasons. Reason number 1, I can follow what the heck you were doing. Reason number 2, if you make a mistake, you can follow what you were trying to do. Okay. All right. 1 minus cosine squared x. Guess what? We can replace that with something. Do we have an identity that involves cosine squared? Yeah. Okay. We have this Pythagorean identity, sine squared plus cosine squared equals 1. Guess what? We can rearrange this. Okay. I could say, all right, I want to move the cosine squared to the other side. So what can we replace 1 minus cosine squared with? Sine squared x. Okay, I use the Pythagorean identity to make that substitution. Okay, now what can we do? We have sine to the what power? We have sine to the third power. Oh, we've simplified our expression. Comments, questions, concerns? You would like to what? Oh, I can't help you with that. What? You're concerned? You don't like this. This is awful. Don't think that. We've done one example. Let's do another one. Okay. Remember, the things that make us uncomfortable are the things that cause us to grow when we're talking about schoolwork here. So some of you might feel a little uncomfortable right now. It's all right. You're growing. It's a growing pain. Okay. You're becoming better because you're uncomfortable. If it were easy, it would be boring and comfortable. I said schoolwork, and you heard me say that. You didn't listen then. All right. Sine of x plus cotangent of x times cosine of x. What about cotangent? Well, there's probably something with it. Okay, well, sine and cosine, they're pretty basic, but cotangent's not so basic, right? What did you say? Cotangent is the same as cosine over sine. So when we multiply this out, we have the sine of x plus cosine squared of x over sine of x. Okay, think of this. Any expression that's not a fraction is like blah, blah, blah over 1. So this is like cosine over 1. So when we multiply, we have cosine squared over sine. Well, interesting. Now I'm adding, and one of my expressions is a fraction. What do we do if we're adding like 5 plus 3/7? We make common denominators, just like we would in basic math, just like we would in algebra. We need to make common denominators. So this already has a denominator of sine of x. What I'm going to do is I'm going to take sine of x and multiply it. You know what? I'm going to run out of room. We're going to multiply by sine of x over sine of x. Okay. So what we've done is we said f squared x plus cosine squared x all over our common denominator of sine of x. That was nice, wasn't it? Why is it 1? We have a Pythagorean identity. We know that sine squared plus cosine squared is 1. Hank, is there something else we can do? We know that 1 over sine is the same as cosecant x because it is a reciprocal identity. Yeah. So next year when you are taking derivatives and integrals, sometimes we need to do this in order to be able to do that. You don't know what those are, so it's really hard for me to explain that, okay? We also are going to get into situations next week where we're going to be solving trig equations, okay? So being able to like make things simpler before I set equal to 0 sometimes can be beneficial, okay? Right now we have to understand how to do it so we can apply it in our calculus days. This is also a really good exercise for you in terms of logic and perseverance, okay? Both of which I think we all are going to need in our lifetimes, right? Okay, next one. What? Okay. You're just trying to make me mad. Okay. Now, this example, I want to talk about, if we have 2 or more terms in our numerator, we can split the fraction up. But if our denominator has more than 1 term, we cannot split the fraction up. Like we can't say that this is 1 plus 1 over sine of x. That is definitely illegal. Okay. Well, then how are we supposed to do? Okay. Well, I'm going to introduce this strategy called multiplying by the conjugate, and we'll talk about it again tomorrow. But watch what happens. Remember what a conjugate is? A plus B and A minus B are conjugates. And when you multiply conjugates together, we get the difference of squares. Okay. So if I have 1 plus sine of x, I'm going to multiply it by 1 minus sine of x. Now, can I just like multiply by 1 minus sine of x? We got to do it upstairs too, right? Multiply by the well-chosen 1. Okay. Well, how is that helpful? Well, when we multiply by the conjugate, we get a difference of squares. So we get 1 squared minus sine squared. What do you notice? One minus sine squared. Cosine. Okay, remember we have this Pythagorean identity that we're going to have to be able to work with as is and moved around a little bit. So if I readjust this Pythagorean identity that I wrote up there in red, we could rearrange this to be cosine squared equals 1 minus sine squared. Okay, so we can rewrite this as 1 over, 1 minus sine of x. Let's try that again. 1 minus sine of x over cosine squared x because of our Pythagorean identity. What's wrong with that? What's wrong with that? You went, ugh. Oh, I'm with you. Okay, well, now we only have one term in our denominator, and that's helpful because now we can do that splitting of the fraction. We can say 1 over cosine squared minus sine over cosine squared. Split. Don't split the fraction, split the fraction. So let's simplify these two fractions that we have now. We're almost there, people. We're almost there. What is 1 over cosine the same as? No. 1 over cosine? Secant. So 1 over cosine squared would be the same as secant squared. Nope, not even a little bit. There's no division in the Pythagorean identity. Okay. Now, what about sine over cosine squared? That's kind of strange, right? Oh, I think a tangent's going to be involved. I think you're right. But we have like an extra cosine left over, right? So we still have that cosine in the denominator, right? So we know that sine over cosine is tangent, but we still have cosine in the denominator. So we can think of 1 over cosine, which is secant. Blowing your minds. So we use the quotient and the reciprocal identities to get there. Now, some of you might argue, how the heck is that simpler? I'm with you. I know. We don't like having addition or subtraction in our denominator, which is why that was what we needed to do to fix it. Some of you also might be feeling, no one has done. Okay. This is going to be kind of a weird assignment to where maybe you check the back of the book or you check Calc Chat and you're like, oh man, I wasn't quite there. What we do tomorrow, we are going to use these skills, but we're actually going to know when to stop. Today's going to be a little weird. Your homework assignment is going to be, it could be frustrating. It could be fine. Just for the fact that I don't really know when to stop using these identities. So use Calc Chat to help you. And if you look in the back of the book or you look in Calc Chat and you had a little bit further to go, it's okay. Tomorrow, you'll know when to stop. Okay. Now, we're not going to go all the way through this one, but I just want you to tell me what our first step would need to be. No. I am adding 2 fractions. We would have to make a common denominator, okay? If we have time, we'll come back to this one, but I want to make sure I get our last example in because it's a little bit unique, okay? All right. This is something that I use with my Calc 2 kids. It's a concept called Trig Substitution. So I want you to write down that x equals 2 tangent of theta. And we are going to write the square root of 4 plus x squared as a function of theta. So just write those things down that I highlighted. Okay, so this is what we're going to start off with. We have the square root of 4 plus x squared. But what is x? Okay. Now, if we have 2 tangent theta inside of that square, couldn't we write that as 4 tangent squared? Yeah? Look how cool this is. Okay, now, let me point something out to you. If I take the square root of what is this? The square root of 13, right? Not the square root of 4 plus the square root of 9. Excuse me, do you see where I'm going with this? We cannot break up a radical. What was that? The shelf fell? Okay. Square root, we cannot break up a square root with addition or subtraction underneath. Okay. Instead, what do you notice about the 2 terms underneath? They both have a 4. So we can factor out a 4. Go back up to your identities. Nate, do you see somewhere where it says 1 plus tangent squared? You don't. How about the Pythagorean identities? Yeah. Squared. Yeah. 1 plus tangent squared is the same as secant squared because of our Pythagorean identity. Now that we have multiplication under our radical, we can do that. We can take the square root of 4. We can take the square root of secant squared. Basically, we use our trig identity underneath the radical so that we could actually take the square root. Okay, I think we can do that last problem. Let me do it. How about this? You can choose whether you want to write it down or just watch me. You're just gonna watch? Okay. What did we decide our first step needed to be? We need common denominators. So this we are going to have to multiply by 1 plus cosine of x. And this one we're going to have to multiply by sine of x. Okay. So we have sine squared plus cosine x plus cosine squared x all over our common denominator. So I made a common denominator and then I added our fractions. Do you notice how my common denominator I kept factored out? Okay. Now, what's something that you notice? What is sine squared plus cosine squared? It's just stop. If you and I contribute in a meaningful way. You're just being obnoxious to be obnoxious. No, you weren't. What is sine squared plus cosine squared? So use the Pythagorean identity to get sine squared plus cosine squared is 1. Now what? Yeah, those are going to cancel. And what's 1 over sine? Oh my goodness, that's so simple compared to what we originally had. I don't know why I was worried about time. We got through that, no problem. Here's the deal. I am not giving you credit for your homework if you skip a problem without even trying one thing. I realize that there may be some problems that you have a hard time getting to the end, but you are going to attempt every problem. Otherwise, I'm not going to answer your questions. Okay? You will attempt a problem, and if you get stuck, we'll talk about it. But if you just don't even try, I'm not going to help you. You have to try. It's give and take. Okay?